Welcome back to the Climate Solutions News podcast. I'm Dominic Shales. Aviation is the hardest transport sector to decarbonise. Batteries are too heavy, hydrogen's years away at scale, and the sustainable fuels that do exist mostly depend on feedstocks in short supply. So the search is on for a fuel source that's cheap, abundant, and genuinely low carbon. My guest today thinks he's found one in a place most people would rather not think about: human sewage. James Hygate's the founder and CEO of Firefly Green Fuels, a Bristol-based company turning treated sewage into jet fuel. It has a first UK plant in development and a near $1 billion offtake deal with Wizz Air already signed. James, welcome to the Climate Solutions News podcast.
Oh, hi, Dominic, and thank you for having me on today.
Take us back to that moment that you discovered biosolids, as they're called, as a feedstock. You tried every approved route and drawn a blank, I think. And what made sewage different? How did you get to where you've got to?
Good question, because this is although Firefly is relatively new, it's I suppose, a startup 20 odd years in the making. So I actually started a company called Green Fuels back in 2003, and we set up biofuels equipment all over the world using waste oils and fats. And it was really 15 years ago we recognized there was limited feedstock. So spent best part of a decade looking at everything and trying everything out there, because we set ourselves a lofty goal of decarbonizing aviation, and with the aim to do it actually in its entirety. So you have to it's a gigaton level to do that. And we looked at every waste, we looked at every material there, every process, and it was either too expensive to make, or you couldn't necessarily meet the sustainability side, or just too complicated a process. And we started looking at wet materials and say, okay, well, there's a lot of wet biomass out there, and there's lots and lots of it from different processes, which led us to looking at sewage. I think it was just a meeting that we had together to look at these maybe alternative ways. And you pick up the newspaper every day, and there's always an article about sewage, so I figured there's probably a lot of it. Turns out there's probably a term for the quantity that's out there, which is a lot, but there's many millions of tons of this material. But it's currently spread on farmers' fields. But what we learned was actually that's getting phased out for a number of reasons. I can come on to that later. So it seemed like the ideal feedstock. So it wasn't I wasn't sat in the bathroom one morning and thought, oh, guess what? I can turn this into fuel. It really was a long drawn out process to actually identify this as the ideal feedstock for making large quantities of cheap SAF.
And before we get into the technology, I mean, you've said you're changing the world one stool at a time, and behind the joke, how big is the resource actually at scale, and how much sustainable aviation fuel could the world's sewage realistically produce?
No, it's a really good question, and this is why we got so interested the first time, because it was making sure when we look at feedstocks, how abundant this was, and actually could it be available everywhere in the world. And obviously with sewage, it's everywhere. And when we talk about sewage, we take this material right at the very end of the process called sewage biosolids. So this is the output of anaerobic digestion, currently gets disposed on farmers' fields, and it's getting, the current disposal route is disappearing because of forever chemicals, microplastics, and metals contamination. So around the world, this is kind of now getting phased out. So it's a problem waste. When you look at the quantities of it, there are millions and millions of tons. So in the UK, when you actually look at the volume of sewage that's out there, it's about, assuming we could get all of the sewage biosolids, and as you can guess, we're quite popular with the water companies at the moment as being seen as an outlet for it. You look at the 2040 mandates for SAF, it's probably something like a third of that mandate that you could produce from sewage biosolids. When you go to some other countries, the US, for example, our partner in the US is a company called Synagro. They process 16 million tons a year. If you can convert that into liquid fuels, you would double the US output of SAF. So these are big numbers. But the interesting thing with this pathway that we're developing is actually it gets much broader than that. So when you look at other wet wastes, animal slurries, other digestates, anaerobic digesters, and these are all, this is all regulated. So these are real numbers that are out there because they're regulated industries. Yeah, you can decarbonize aviation in its entirety, which is kind of mind blowing. I'm sure we're not the only ones who've done those.
Which is incredible, isn't it?
Yeah. There's a lot. There's just millions and
But,
millions of this material out there, basically.
and how many competitors do you have also working in this space, or are you genuinely kind of forging a new path?
So I suppose we are literally forging a new path. So this is before the fuel can be used in commercial aircraft, we have to get it qualified with ASTM, and we're going through that process at the moment. So this is our own specific pathway. It's called sewage biosolids to jet. So we're moving that through ASTM at the moment. We also have IP across the process, but also around the various other outputs from the plant. So what we're trying to do is develop a very clear moat around our castle, essentially, that we developed here, and we're using sort of the best in class partners on this journey as well. So if you look at the downstream hydro treatment of our process, I'll get a bit on the technical side down the line. Our partner there is Chevron Lummus Global. Their techs used to produce about 60% of world's jet fuel, so the biggest in the world. And on the upstream side, we've tested every HTL, which is a technology provider you can imagine, and with our specific feedstock, and the one we're working with is a big outlier. So we've built something to give us not to stop competition in space, but to give ourselves a very significant head start to take this on, because we set this business up with a very specific purpose, and actually you'll enable us to do it. But as in anything that you have a big lofty goal, you need to do it with friends and partners. You can't do it alone.
And you use the acronym HTL, which is hydrothermal liquefaction, if I'm not mistaken. Do you want to talk us through the actual process? How does it work? What are the different stages of the process and the different inputs?
Sure. So it's a hydrothermal liquefaction has been around since the 1970s. It's a process to look at its most simplistic form. It's like a pressure cooker. So you take in wet materials, so wet biomass, and this is the interesting thing with it. You put it under sort of relatively high pressure, kind of moderate temperatures, to the point where the water becomes reactive and it breaks down the material that's in there. And because we use this output from AD, actually breaks it down quite nicely, and you end up with a bio crude, which is very similar to a fossil crude, and a biochar, and obviously water. And this is when we found the wet material, like biosolids. Like, okay, this stuff's amazing. There's loads of this stuff. It's 80% water, and that's the challenge: is removing the water ahead of processing. We looked at whether drying it and pyrolysis and gasification, and you have lots and lots of process steps to get to a point where you can have something to turn to fuel. The nice thing with hydrothermal liquefaction is it's basically what happens in the Earth's crust, right? It's put it under high pressure, it breaks the material down, and you end up with this output of a crude oil. Although the crude oil, it's fresh, it's got nitrogen, oxygen, it's got other stuff in there you've got to get out, but essentially that's where it is. Then the downstream side is it's hydro treatment. Although it's specific for our crude, it's something that the oil and gas industry has been doing for 100 years. So it ticked the box for us as being a relatively simplistic process. So that means costs will be lower. Got a really low cost, negative cost feedstock that's going out one side, which will then provide a sort of a value of product at the end that the airlines will adopt in large quantities. And so these were the key things that we looked to doing it. But as a process, it's quite elegant, really, with its simplicity. All of my engineers going to be listening to this and say, flipping out, it's really, really complicated, James, because they're obviously getting the conditions right, making sure the thing, there's a lot of engineering complexity around the process to do it and to do it at scale. But actually the chemistry is relatively simple. And, you think about fossil fuels, they're still biofuels. They take millions of years to make. This is a way of speeding that up into a much, much faster process.
Very good. And Cranfield University did some research putting the carbon saving at around 92% versus fossil jet fuel. How just talk us through a little bit how that was measured, and what's included in that figure in that comparison.
Sure. So when you look at this is the overall life cycle carbon assessment of the fuel that's produced, and so for that you take into account the movements of products around, etc. So there is a carbon intensity of fossil jet as the baseline you're working against. So you look at our process. So actually, it's relatively local. We're using material that will be sourced in the UK. There's an existing ecosystem that consolidates this material into sludge treatment works, which is great. These sludge treatment works, currently material goes into trucks, which then go into farmers. You don't go out on the road to farmers' fields. What we're doing is we have upstream sort of HTL plants, which will turn this material into a crude. So it's a smaller volume of materials than leaving those sites, which then go to our centralized refinery. So you look at the overall sort of logistics side, there's a big carbon saving on that front. It's fully biogenic. This is a material, we're eating plants, animals, etc. So the carbon that's going through us and coming out in this process has been really recently fixed, but it is fully biogenic. So that is a massive point for the overall carbon saving. And then when you look overall for the end-to-end sort of the energy consumption, it's relatively low compared to other routes to SAF. So that 90+% was based on, that wasn't taking into account any carbon capture at all. We have a biochar though that does go, that will go into a fixed source. So it's worth noting that the biochar does come into that account because there's fixed carbon in that process. So that will go into aggregates, or eventually it would be a fantastic soil improver once that's certified for use. But we hadn't taken into account further carbon capture and storage. And we do have quite a lot of CO2 that comes off the HTL parts, which now has a potential value for us to look at as well. So there is the potential to get this effectively to a carbon neutral or a carbon negative fuel.
Very good. You mentioned the complex supply chain. In May, you signed an agreement with a Turkish company called Altaca for their HTL technology. And at the time, you said that was the final link in your supply chain. So what do they do? Why go to a Turkish partner for that piece? And what does it unlock that you couldn't do before?
Yeah, so it was, I suppose, going back to what I was saying earlier, we've got a pretty, there's a good reason why we're doing this, and it's to have the scale of the impact. And so for that, we're working with what we believe the best in class providers for each end of this process. So with Altaca, their process, we tested lots of them, and it works particularly well with our kit. But obviously, we delve in deep. It's a real deep understanding of the chemistry and the engineering alongside. These units are essentially modular, and there's so it's something that can be. They're a big engineering company, and they have some significant capabilities that can get us to market quicker as well with this material. So for us, they were absolutely the right partner from the HTL side. We have on the downstream side, as I mentioned, Chevron Lummus Global. They're really key because if you look at the production of jet fuel, their technology produces most of this. And so if you're looking at maximising the amount of SAF, they're kind of the ones you need to work with. They're fantastic, and we have an exclusive arrangement with them for our specific crude. So it's like we rocked up with initially sort of 20 litres of crude oil, said, we've turned this in jet fuel, can you do it? And then they looked at it and said, wow, okay, we can make, there's a lot of refineries that can go out into the world to process this crude oil. So we're no different really to CLG, I suppose, to someone who's pulled it out of the North Sea. It's just that we've made it out of sewage. So they were two key partners with us. Wizz Air, amazing with the offtake agreement was put in place, and that's a big deal. That's 15 years. That enables us to go to banks. We have agreement, or we're working with most of the water companies now in the UK, and are getting sort of firmer agreements in that. And so there's very quite high level sort of letters of intent, etc. will move towards contracts on the feedstock supply. So we're very confident that we have the input material, access to more than we need for the first facility. We have a buyer at a scale for a long enough period of time to finance the downstream part. We have de-risked the technology by using proven technology that's been used for, sitting on the upstream side, been used for other applications. The downstream side has been used for turning oil into fossil jet for many, many years. We're locating at an existing refinery in Harwich. That's with Halterman and Carless. And so there's about 80% of the infrastructure we need is already there to put in. And then on the upstream side, again, so jumping around, because the HDL plants are going at the wastewater treatment works, again, it's access to site there. So we've got all the pieces of the puzzle, basically. Great investment, Dominic.
And you very, very good. We'll come on to the investment in a second. In terms of the Harwich plant, so what's your timing on that, and what still needs to be done for that remaining 20% to get it fully operational?
Sure, that's really interesting actually, because it is kind of linked to investment as well. But the when you look at the Harwich site, it's an existing relatively small scale refinery for upgrading light distillates, and it's fantastic. The people there are amazing. The site is just perfect for what we want to do. So there we're building a hydrotreater, and once the fuel is hydrotreated into a light distillate, it can then go through all the fractional distillation, the blending, storage that's already existing there on site. And so that's a way to sort of reduce the deployment costs and actually reduce the timeline for production. To be honest, the two most important things out of having the site there are there's a lot of people there that know how to run a refinery and make this fuel already, so that's great. So that can be done. Also, it's a top tier CONA site, so planning and permitting is relatively straightforward for what we're putting in there. So it's a way to fast track that. So we are, with our current plan, that will be the facility will be in operation sort of 2029. So it's a few years away from being in commercial production, but actually relatively short when you look at the timescales it often takes to build the larger plants. On the upstream side, so we're building a demonstration facility at the moment that's in construction that should be operational end of this year. See that as the first stage of engineering for converting the biosolids into crude oil. That can then get us to a point of saying, yes, this is now proven with our specific feedstock at a scale that can then be financed. And this is where when you look at the investment side, you move away from being sort of, having sort of venture type investment to more project type investment and debt investment. And it's looking to get to that route as quickly as possible. And so we're in an investment round at the moment, which is due to close over the summer, basically, that the funding that we're getting for that is through a fund called Skies 50, and their LPs are a number of sort of strategic airlines, etc., that are coming in there, which can all see. We like it because they can see the significance. And also Boeing have announced that they're investing at this stage. So we've got some really cool partners that are coming in. But once we've got that investment closed, that gets us to the final investment decision, so to FID on the plant, which enables us to fund and get all this built. That's the plan. If it all goes to plan, not quite as easy.
Well, congratulations on Boeing and the others you mentioned. I mean, is this being treated as a sort of as a first of a kind investment, or what's been the skepticism or resistance towards it, or have you found it quite easy to go out and raise the money?
Yeah, so it's definitely never easy. What we do have, so the things we have on our side, we have the feedstock, and we've got the offtake, which is great, and we have a business model that shows an exceptional return on investment for this. The downstream side is TRL9. It's a small hydrotreater. LG can provide the guarantees to sit behind that to fund that part. So that's all. So for kind of half of the overall investment, it's pretty. It's pretty straightforward to get to the debt type funding that we need to build these sort of multi-100 million pound projects. The upstream side, so the investment round at the moment is really to demonstrate at the appropriate scale and for the appropriate time the use of hydrothermal liquefaction with our specific feedstock. So although it's been built at the scale that we're actually deploying and using at the wastewater treatment works, it hasn't been. It's been with things, other materials like plastics or lignocellulosic materials, not with sewage biosolids. And so the funding we so at the moment it's a $40 million round that's going through at the moment. It's to finish the construction on the demonstration and to get us all the way to FID to de-risk that fully, so we can then fund this. And the idea, we've got this project in Harwich and it's amazing, and it will be, and it is the kind of the first of a kind for what we're doing, but we've tried to de-risk it as much as possible. And we've also tried to make sure both the upstream and the downstream are as modular as possible, because this is clearly something can happen everywhere in the world. And when you look at the scale of the impact that we want to have, so, background in greenfields, we deployed biofuels technology, I think it's close to 90 or just over 90 countries. So we rolled that out all over the world. Modular units you could deploy there and actually sow the seeds and get the industry going, and have a carbon impact in the tens of millions of tons of saving, which is phenomenal. But when you actually look at the scale that this can reach, it's mind blowing. So we're doing everything with that purpose in mind, to say how do we save a gigaton? How do we save a gigaton of carbon a year for forevermore? So anyway, that's
very good.
That's my
very good.
that's
The policy. The policy landscape's been quite beneficial to you as well in the UK, but also more broadly. The SAF Act became law in March in the UK, and that has a revenue certainty mechanism attached to it. Has that helped you in making the investment case, or is it still really too early to tell the impact of the policy?
I think so. The reason we're doing this project in the UK is there's a few reasons. Firstly, we're here. I love the fact that this is something that's been innovated in the UK, and the first of a kind will be in the UK, which is great. I think that's something that's very important. The UK also, with the SAF mandate specifically, has the best environment for a production of sustainable aviation fuel, and specifically one that kind of makes money, and ours looks like one that's going to make money. So they're really important. Revenue certainty mechanism is really good, and I think we do need to get that in place. But there's a timescales that are built around that to provide that certainty for the investors. So time will tell whether that's needed or not. We're trying to have a model that shows that this can be done anywhere in the world. In fact, it can be done in unincentivized markets, which is really important. But in the UK, certainly for the first of the kind, all of these things are going to help get these things across the line and actually get them funded. Ultimately, any of these projects need to be real businesses, and they need to make money, because that's the only way you can scale the impact. If we only ever did the one project in Harwich, it would be amazing. It'd be a phenomenal business, but it wouldn't actually meet the purpose that we set out to do. So it's really important that that's always looked at. But you're right, UK is the right place to be doing this, and it's a UK feedstock, right? We're all making it every day. There's loads of it, so it's a good thing to be doing.
Lots of people making it everywhere else as well. Where are your future plans? Where are you going to go next after the UK?
Yeah, so it's very likely that there'll be some announcements later in the year around the project in North America. So we've been looking at locations around that. Again, it's because of the partnership with Synagro, and they have vast quantities of feedstock material. We also have partnership in Latin America with a utility called Sanepar, and they're expanding and looking to do work there. They're the ones who are in the public domain. As you can imagine, put a dot on a map, and someone's contacted us about this, because this material is everywhere, and we're quite different, I think, to any other SAF business out there, is that we are feedstock driven. We have, people are contacting us about the production of SAF. We exist to decarbonise aviation, but actually we solve this this wastewater treatment challenge that's out there. So almost all of the inbound that we have and the interest in the countries that are looking to deploy this say, okay, can we build this into our standard infrastructure for the treatment of wastewater? And if you look at actually on the wastewater side, it's moved from just going into the sea to then a bit of, some treatment and then disposing of it, and then all the way through to anaerobic digestion. Actually, now it's really quite sophisticated. We get a lot of value out of the material before it goes out, but there is still this product at the end, and this product at the end has been it's been fine really to spread on farmers' fields, but because of the contaminants that have been more recently found, the industry is saying we need to move that disposal route away. And the thing it really reminds me of is so I started a company called Green Fuels in 2003. And basically I just wanted to make fuels for running my car. There wasn't a biofuels industry at the time. I worked out how you could do it. So I built a small refinery in my parents' garage to turn cooking oil into fuel. Anyway, that business, it turned into a business when it went on telly and kind of, he was this crazy kid.
Don't most people brew beer in the...
Well, that was it. But I'm a zoologist by background, and I studied climate change. I left university thinking we're going to have loads of fires all over the place. It's going to be really hot. Guess what? It's but the big message I got from that was don't use fossil fuels. And so I was like, okay, well, I can't use fossil fuels and live in a house that's solar powered, got batteries, drive electric cars and all this stuff. But years ago, I was like, well, what I can do is I can work out how to run my own vehicle on fuel. Anyway, green fuels started. But what really kickstarted green fuels was something called the Animal Byproduct Order, which banned the use of cooking oil in animal feed. And suddenly what was a material that could be disposed of into animal feed, that disposal route disappeared and it went onto the market. And we're seeing, and in large volumes, and we're seeing something very similar with biosolids, but in a far, far greater scale. Also, 20 odd years of learning from mistakes and challenges in the biofuels industry can suddenly now apply all of that knowledge to what we're doing now, like the offtakes, like locking in feedstock, like this, that, and the other. So it's been a journey, a really exciting journey to date for sure. But yeah, I can definitely see that we can hit the purpose that I set out to do. And, that's it's quite a nice place to be, but the annoying thing is, I said it to someone else recently, once you've worked out you can fix this massive problem, you can't not do it. It suddenly consumes you. Otherwise it's quite a hard weight to carry. I think you've suddenly worked out how to solve the hardest to decarbonise sector, right? And it is, you can fix everything else. You can't do anything with aviation other than SAF. But at the moment, there's basically no second generation SAF. And there's some, and this is a way to get into, vast quantities of it and actually, thought experiment to the point where it's all of it. So, yeah, anyway, so quite passionate about it. It is very exciting.
Well, yeah, no doubt the passion comes through, and it's brilliant. And I wish you the best of luck with it. It sounds like a genuinely transformative route. So, really, really crossing fingers that it comes off in the way that you've been describing.
Oh,
so, James Hygate, the CEO of Firefly Green Fuels, thank you so much. If the numbers hold, a stream produced literally every day all over the world could become a serious source of low carbon aviation fuel, and, as you've talked about, really solve a disposal headache for the water industry at the same time. I can't wait for the plant to come online at Harwich and start producing. It'll be a very exciting day. For anyone listening today, please do subscribe, do share the conversation, and follow us on our social channels. But in the meantime, thank you very much to James Hygate for joining us.
Oh, thank you. Thanks. I really enjoyed that.